Welcome to the annual Defcon convention. This meeting was held in exciting Las Vegas, Nevada from July 9th through the 11th, 1999. This is videotape number 36, HERF guns, EMP bombs, and weapons of mass destruction.
Guns, EMP bombs, and other fun stuff. Please do not try this at home. You tend to vaporize, and I would hate to see the headline, Hacker Convention vaporizes small children. Winn?
Gonads OS.
I'm sorry?
Gonads. We'll get into the gonad.
I'll talk about your gonads.
The only thing I need to ask is because this is a very, very serious subject, and it is an unclassified briefing, I need all feds to leave. NSA guys who leak stuff to me, you can stay. HERF guns, you've heard about them. I first got involved accidentally by them by testifying before Congress 10 years ago, and I was talking about the HERF guns and the effects that they can have in destabilizing, denial of service, and all that stuff. And it was oddly enough in front of who is now Secretary of Agriculture. He was then Congressman Dan Glickman. And we talked about that a little bit, and he said, Mr. Schwartau, these HERF guns, do you think we should add them to the Brady bill? They were talking about banning the entire microwave and communications industry out of existence by putting them on there, and that's why I guess he's over in agriculture right now. What is it going to be? We're going to talk a little bit about the technology behind these things. People, I get a ton of email. How do I build a HERF gun? Where do I buy a HERF gun? Will you sell me a HERF gun? And yet nobody's really considered out there that HERF guns are not all made alike. There's lots of different ways to achieve the effects of denial of service through magnetic means. And we're going to kind of cover this a little bit technically. How many people here have an EE background? All right, so we can get into it a little bit. If you have some questions, just shout them out, and we'll work our way through so maybe we can get back onto time a little bit. Some real simple basics, just for those of you who don't have some of this EE background. Voltage, amperage, and power. Real simple concepts. That's what makes all this crap work that we're using all the time. Difference of potential equals voltage. Have a lot of voltage, it creates current. Current's those electrons or the holes going up and down the wires. That's the stuff that hurts when you touch it. The voltage doesn't hurt so much. The current is what hurts, and the amount of current is determined by the amount of resistance through very simple formulas that we all learn in Electronics 101. You don't need to memorize these, but they are kind of nice to have at your disposal later on when you're talking about these subjects. The other thing that people tend to forget when we're talking about this area is a megawatt, a terawatt, a gigawatt. How much power am I going to jam down the throat of that NIC card? How am I going to really destroy things? People say you cannot get a gigawatt out of a small device. The problem is people don't think about time, and it's all about division of time, and the difference between continuous power and peak power, or pulse power, spiked power. If I have a 1 watt source of power, just 1 watt, which is 1/100th of one of these light bulbs, and I release all of the energy in that 1 watt circuit in 1 microsecond, how much power have I released? 1 megawatt in 1 microsecond. It's very simple concepts, and time becomes very, very important when we're looking at HERF and EMP and the kinds of effects that we're trying to generate. The taxonomy for HERF, for those of you that are interested, there'll be an article on this in Popular Science. I believe it's in the August issue coming up. There's numbers of different types of ways to generate this that we're doing militarily here in the United States, that are done for fun by hobbyists, and are also being done by the Russians. And I'll show you some of the Russian technology you can buy on the internet now, that is now made available here in the United States. System susceptibility. We have to understand what are we trying to do as a bad guy attacker with a HERF, what's he going to do, and how do these systems get affected? And there's 2 fundamental ways that they get affected. One is through the back door. The back door means through the power lines, through direct apertures, the holes in the computers or the electronic systems, whatever those happen to be. We deal with concepts of resonance as well, tuning the attack mechanism to the same frequency of the system that's under attack. It heightens the effect and the susceptibility of the equipment that is under attack. And this is exactly what the military does with some of the weapons that I'll be showing you in a couple of minutes. Getting the power inside of these things is pretty trivial. And the reason it's trivial is that it's not heavily shielded. Anybody ever have the old VIC-20s and trash 80s about 25 years ago? What's your TV set look like? Your TV set looked like hell because it was radiating out the crap from here before the FCC got involved, and it made the TV a little bit of a mess. Now, I got HERFed for the first time, I'm guessing it was about 72 or 73, and I had a pregnant roller skate on the highway, which was a Volkswagen. And we were driving along, and that's all I could afford. Come on. As I was 20. And we had a 9-foot whip antenna on the back, and inside of it was my $30 Radio Shack CD, so I could speed down the highway in my Volkswagen, obviously. The truckers did not like this. They were not happy about it because we were interfering on their channel 19 breaker, all that stuff. So what they did is they would get 500-watt linear amplifiers, put them on their CDs, and squelch when they drove by a little four-wheeler. What happened to my $30 Radio Shack CD? Puff. Yes, that's a technical term. Puff. And they would absolutely smoke by just overloading the circuits. And that was, in distinction to the back door attack, that is a front door attack. The front door meaning when you're using HERF or EMP against a system that has a front coupling system, an antenna of some sort, where there is normally a signal to be put in or to be received. Same kind of thing with satellites. I'll show you some of that. The satellites that have transponders, how do you shut them down? You do a front door attack using this technology. Now, ESD is one that is often overlooked. Electrostatic discharge is a very, very simple form of electromagnetic electrostatic denial of service. Same thing with the fingers on the dry carpet, especially out here in Vegas. You touch the doorknob and ouch! You're getting about 500,000 volts through your fingertip, but at very, very, very low power, but it still hurts because it's burning off the surface of the skin. At the other end of the spectrum, we have lightning. Lightning is doing hundreds of thousands of amperes at thousands and thousands of volts, which is a tremendous amount of power. I happen to live in the lightning capital of the world, Tampa Bay, and we have to have very special equipment on our house just to keep our networks up and running because we're down on the average of 10 times a month for most of the community. So we're seeing these types of things normally around where we all live and they're just normal experiences, but this is a technique that can be used offensively, and I'll show you how some of this works as well. The one that we all think about initially is the nuclear EMP, the stuff they discovered back in the 40s when they were playing with the ships out in the Pacific, blasting off the nukes, and suddenly the communications and power went. And the scientists say, oh, whoops, we forgot to tell you about that little side effect that goes on here. The military has looked at this very, very seriously, not in the nuclear realm as much, but in the non-nuclear realm. The idea is how big a pulse can we put off, or can they put off against an enemy at between 500 and 1,500 meters above ground. Now, running around with a whole bunch of nukes is not good public relations for the United States. So they look at the non-nuclear way of generating these things. Now, the spectrum, the frequency spectrum of what occurs in these types of pulses is intriguing as well because it's a fairly narrow band. It's between roughly 100 kilohertz and 100 megahertz. And it's a very, very noisy signal. But the effect is not to particularly target one specific system or vulnerable target. It's to take it all down at once. These are the spikes. This is what these types of attack tools look like over the time domain. And if you'll notice the blue line, that's some of the new technology that's being developed for the non-nuclear EMP pulses. They're called flux compression generators. And I'll show you how some of those work in a minute. But notice the time scale, that it's a very slow ramp up, peak power, and then it drops off almost instantaneously. The yellow line is something we're going to talk about a little bit later. It's the transient, I'm sorry, that's the nuclear one. I'm colorblind. Which one is that? That's the yellow one. What does that say? Lightning strikes. I'm colorblind. It's awful. The lightning has an instantaneous peak power, but then it drops off fairly slowly. And there's actually, when the lightning strike goes off, you see the one, but there's multiple subsequent effects. There's the equivalent of the earthquake aftershocks that occur. The nuclear pulse is the one on the left. That is absolutely virtually instantaneous. We're down into the picosecond ranges here, with huge amounts of power compressed again from a time standpoint, which makes the EMP from both the nuclear and the nuclear much more efficient in the way it's being done in the non-nuclear format. Distance is something else that becomes really, really critical when we're dealing with this. The concept of can you hurt somebody from 10 miles, 20 miles, 50 miles becomes a mathematical problem, and it's an engineering solution that comes out of it. Cars, everyone says, can you do this to a car? We measure cars' susceptibilities to these types of effects in what is called an E field, the voltage field. How much voltage can you put across a car before it shuts down the electronic ignition systems? The answer is roughly, with the shielding that Detroit currently uses, about 200 volts per meter. That's about it. They do testing in electronic anechoic chambers, which are free field conditions. Then they surge the cars with the generators to find out how susceptible they are, and that's the current set of specifications. However, if we start looking at the charts here and look at the attenuation factor, that if down at the bottom here I'm dealing with volts per meter in my E field, and if I am able to generate 1 million volts per meter at the antenna source, you look at the attenuation factor, or how much is degraded over distance, and at 1,000 meters, a kilometer away, I've still got 1,000 volts per meter, which is going to have a significant effect across most automobiles. And I'll show you some of the technology that's being developed on how to do that. So the attenuation factor is quite critical when people are saying how much power they're generating. And if we're dealing with power, there's one attenuation factor. If we're dealing with voltage, here are the formulas here. And there's a whole series of these that exist to be able to figure out how powerful the weapon systems that are being developed really are. This is what the military wanted. After the Gulf War, the Southern Command, based in Tampa, Florida, said, this was with Schwartau, we really, really wish we had an EMP weapon that we could have just dropped over all of Iraq, shut down all communications and power in with one explosive device, and take it all down. And that is what has been developed over the last several years by various folks within the government. The way it's being done is with called a FCG, a flux compression generator. And its fairly simple concept is that up there on the left, there's a small amount of explosive charge, conventional explosive plastique, something like that. And inside of that tube, you've got various other forms of explosive that come along, and you have a magnetic insulating tube of copper. The explosion that is created is somewhat like a nuclear, in an atom bomb, is the first explosion, which then compresses all of the energy, the magnetic energy that is being driven into there, down the line to come out in a coherent form. And in these types of weapons, typically we're in higher frequencies, and these tend to be more in the high-power microwave ranges of what the military is being done, and it comes in two forms. One is very, very tuned, and the reason we want the tuned high-power microwave versions is to specifically target certain systems that are operating at certain frequencies. If you're operating for a front door coupling at a communication system, you're going to want to have the most efficient attack by using similar frequencies. So the narrowband HPM is the technique that they use for this. These do work for a fair amount of distance, and the reason is when we're operating in frequencies between 1 gig and 100 gig, we keep our energy fairly well concentrated in a beam. The dispersion pattern at higher frequencies is not as wide as it is at lower frequencies, so the energy remains more concentrated over distance. In the ultra-wideband version, this says, I don't know exactly what they got, but I know I want to take it down, so I'm going to use a wider spectrum of frequencies in the explosive means, different types of antennas, different types of vercators at the output of the bombs, in order to have a wider frequency effect and, in theory, take down more systems. This is the MK-84 format, which can be used either in a missile or as dropped out of an airplane. And in this particular one, you see the radiating pattern that comes out of it from the flux compression generator. And it's fairly simple. There's a power supply, battery, the ballast, which is part of the FCG, flux compression generator, and then there's a coaxial load, which is just saying I have to have a load in order to be able to do an output in here. And again, it's simple engineering. This is fairly current with what the U.S. military is doing. Another form is going on is called EMI. And EMI is the stuff that maybe saw that 2020 thing with Connie Chung about 2 years ago with the guy in the wheelchair, and he went over a cliff because somebody used a cell phone near his wheelchair. EMI is the electromagnetic sewer around us all. The thing that happens that's pretty interesting is that EMI is normally just a pain in the butt for various types of engineering folks. Keeps the noise out. You want to keep the electromagnetic interference out. The cell phones near the heart monitors, you don't want going in there because they can shut them down. These are accidental pieces that are similar to the electrostatic discharge, except these are in the electromagnetic spectrum and operate at unknown frequencies, and they're basically leakage. It's the reason we can't use the laptops on airplanes, because they've had avionics interference from EMI. But where it gets more interesting is when you have LERF. LERF is low energy radio frequency, and the people that pioneered the use of this offensively were the Russians. And they used a fair amount of this during the Cold War and over in Moscow. For a period of time, there were a whole mess of fire alarms that went off in the U.S. Embassy. Anybody thinking out there? LERF, what they were doing, according to the KGB, who has now come out of the closet on this, is that they were sending energy into the U.S. Embassy on a regular basis, unpredictable levels, but low-level radiation tuned to certain types of equipment that were inside the embassy, causing the alarms to go off, meaning the Russian fire department had to come. They had to be admitted to the embassy, but were they really firemen? So this was one of the techniques that the Russians were using as well. They were also bombarding the U.S. Embassy with microwaves with the diodes in order to be able to confuse our intelligence services using the same types of techniques. This is very, very wideband, simulating the effects of EMI. The whole point is, when the victim does not know whether it's an attack or it's just one of these normal things that goes on. And this is kind of where many of us are right now in this field at the low-level things. The U.S. military capabilities are pretty straight ahead. We have the anti-satellite versions. The power supplies for the ground-based versions of these are 3 tractor trailers, loads of capacitors. And they put out between 10 and 100 gigawatts currently using a 10-meter dish, and they send pulse power up to the satellites for anti-sat things. One of the reasons it's being done is that it technically does not violate putting weapons in space from an anti-satellite standpoint, so they do it from the ground. The HERO program was started by the Army in 1990, High Energy Radio Ordnance, and the object of the exercise is to build little tiny howitzer projectile types of EMP pulse devices, lob them in non-explosively to the adversary's arsenals, who has also electronic devices, to make his bombs all duds. Very simple concept. We have the backpack versions. The Army started developing these back in the mid-80s and have improved them over time, where there are backpack power supply versions and actually handheld gun versions. I've been unable to get any pictures of those, but I do have a picture of one of the Russian ones that I'll show you. Currently, the open source published information that the government provides says they're spending about $500 million a year developing this type of technology. How much is involved in the black projects and all of that, I have no earthly idea at this point, but we could certainly guess, or we could ask some of our NSA friends over drinks a little bit later. Where things start getting a little bit of a disconnect is the concept of asymmetric warfare. And asymmetric warfare means that your adversary is going to operate by an entirely different set of rules than you're willing to operate by. Same kind of thing we went over in Vietnam, similar thing we're seeing in Kosovo. When the other guys do things that are so totally outlandish and different, how do you counter it? And that's kind of what the feds have been saying about hackers for a whole long time. How do we deal with this? In this world of HERF, the fear has been, what do we do about terrorists? What do we do about the really, really bad guys who might have some capability outside of the normal realm? Most of the stuff I've shown you, the military stuff, they're not going to be building that on their own. Yeah, they could build a little electrostatic device. They could build some small things. But a new technology came out about 4 years ago by a man named Dave Schreiner. And Dave Schreiner lives in Southern California. He's an engineer. He used to work for the DOD. Now he's retired. But he's had an interest in how to destroy banks for some unknown reason. So he invented a device called the TED, the Transient Electrostatic Discharge Device. And he wanted to find out how much money, how much energy, how much know-how would it take for a terrorist group, non-nation state terrorist group, to develop a technology that would be roughly equivalent to what the U.S. military is spending $500 million a year on right now. So he started playing with these things, and I'm going to show you some of the pictures of what he did, and ultimately what he did cost $500. The waveguide device, in all microwave types of things, you got to have a waveguide. It focuses all the energy, keeps it all tuned properly. And he built this in his garage out in California. This is the S20. The S20, this thing is, the power supply there is about really big. It's about 3 feet high to 2.5 feet high, heavier than all get out. It's got an oil-filled canister in it. There's certain types of electronics that I'm not allowed to talk about because they may be classifying this. The output antenna that you see there is made out of plexiglass, hand-wound coils, and 2 aluminum plates separated by styrofoam. He built this in 2 weeks for $500. It puts out 1 megavolt per meter at the source. 1 megavolt per meter. If you go back to that attenuation chart, that means at a kilometer in a free field condition, he was left with 1,000 volts per meter at a kilometer out. Did anybody see the 2020 special a couple of weeks ago? Anybody see that? Okay. Actually, the transcripts were on abc.com, but they removed them, and I don't know why. Dave did a demonstration, and he shut down some cars, showed various effects from this device. It was a Corvette that they did. What was Corvette? And it was fairly effective proof. So where is he? He's going now. He's testified before Congress on this, proving the point that it requires a reasonable amount of engineering know-how. An engineering student at any university would have the basics. He runs a machine shop, so he has to have that skill level, and understands some electronics 101. That was really all that was required to build this device. He's now working on the S30 device. He's targeting 2 to 10 million volts per meter at the source, with a projected cost of under $5,000. This puts it into the realm of serious worry when we're talking about potential strikes against the infrastructure. This device is a dual cone horn, and I don't understand enough about antenna design, but from what I am told, this device actually can double and triple the power output of these types of TED devices because of the various geometries that are built into it and the resultant waveforms. I spoke to 2 people actually out here in Vegas in March about this, and apparently this type of antenna design is going to end up being classified, and people are getting picked up for it. So it's another thing I don't quite understand. The Russians have been at this for a long time, and they have actually been in many ways open source about it. There were some reports about 2 years ago about suitcase-sized EMP bombs running around, and it ended up being true. They're called radar devices, and they put out pretty significantly small pulses. They're 2 nanosecond pulses, and they put out about 5 megawatts of power. And if you're talking a portable device, you don't need to be a kilometer away from something. Leaving a device like this inside of a teenage video arcade would be enough to make anybody's day, right? Just shut the whole damn thing down. A casino would be another good target source. Shall I introduce you to somebody? The Nagira is another system that they were doing. It was based upon radar principles, and a lot of what we've seen is that used radar equipment that anybody can actually pick up on surplus from Air Force and military turns into a fairly effective EMP or HPM weapon system because the fundamental technology is there. The trick is, how do you take a continuous, sweeping, reasonably low power 50 to 100 watt output and turn it into the peak power? And the whole trick with this whole thing is, how do you switch huge amounts of power really, really, really quickly? And the Russians have done some pretty amazing stuff with this, and some new technologies that are now coming out, and one of them is called BASS, and it's a special silicon construct in wafers that allows super, super fast high current switching. This is the Russian plasma gun. This shoots out streams of negative ions at high power. This device was somehow acquired by somebody within the United States military who somehow got me a picture of this. And at the left hand is where you insert the power. The power supply is independent of this device, and the output tube is on the right. And from what I've understood and been told at this point, it shoots out lots of power. Yes, sir? The power supply requirement on this device, I do not know. This one, apparently, they got through channels, and it's, I don't know many details on it. I just felt fortunate to even get the picture. But the stuff that you want to buy on the internet, this is some of the stuff you can actually go out there and buy. This device, okay, the watch shows you the size of the device here, and it's putting out 10 kilovolts at 500 amperes. That's an immense amount of power. And it's doing a 1 to 10 nanosecond rise time, which is that very, very fast front leading edge spike, and it's going to send out multiple pulses. The reason to do multiple pulses is to really screw up the system. Single pulses don't always work. There's a degree of unreliability when you do single pulse against any system. So if you're doing 10 kilohertz pulses, suddenly you're going to have very, very high increased effects against your target systems. This is the Russian car stopping device. And again, this is putting out 2.5 kilovolts of power into 50 voltage into 50 ohms. This device is even faster. It's 700 picoseconds, which is less than a nanosecond, putting out an immense amount of power. Ostensibly, it's designed as a coolant device, but the testing against automobiles has been very, very successful. I don't know where they're going, but if you want to buy them on the internet, I will give you the URL at the end of the presentation. I'll give you that, no problem, no problem. How big a Visa card do you have, I think, is the only question. These things are not cheap. How do we solve the problem? How do we solve this? Well, classically it says, let's build this huge Faraday shield around everything, and let's isolate ourselves. No windows, isolate the air conditioning, no metal ducts, completely decoupled power supplies, isolated there so we'd have very minimal transference of power, strong amounts of filtering and what have you. This is really rough to rewire America. It's tough. We're not going to rebuild the infrastructure of this country using this technology because all the architects would get mad with no windows. You can't have windows with this. Another approach is hardening the power supplies of whether it's the computers or any other system. Converting to optical cabling is another way that is very, very efficient because suddenly you don't have the magnetic conduction means. So the communications through optics not only offers the speed, but it gives us some hardening capability against these types of attacks. There's an awful lot of work that will have to be done just even down at the PC level to make any of these systems protected and hardened against the kinds of devices that I've been showing you or the kinds of devices that you can play with at home, and I'll show you some of the things that you can actually do for yourself. Where it's going is how do we detect these super, super, super fast, high-power things before they cause any damage? Back to a detection and reaction system, kind of like an IDS system for HERF and EMP. The Swedes have been working on this for quite a while, and the interesting thing is that the private sector in Sweden knows just about as much as the government sector. They're working together on the problem, whereas here in the U.S., the vast amount of the areas involved in HERF and EMP are super classified. So we don't have a huge disconnect between the private sector and the military doing the research in the area. So the Swedes have come up with a very, very fast, we're down in the very low picosecond ranges here, of detection of certain thresholds of electromagnetic events that may be going on. So once you've detected this event, whatever it happens to be at whatever power, then the subsequent question is, what do you do about it? Well, one of the things that they're looking at right now, and this is a test up, I apologize for the quality of the picture here, is called a high-speed plasma limiter. And a high-speed plasma limiter is a little chip that they're developing right now that inside of it has a plasma field. Once the detector, the high-speed detector, finds out that there's this EMP or HERF thing coming in at it, the plasma limiter will instantaneously, or very close to instantaneously, shut down. Now, this is excellent at the front end of transducing systems or communication systems for the front door coupling. It does not solve the back-end coupling problem at all, but it does solve it for the communications industry, that if we're able to fix that end of it, at least in the event that the bad guys come along, we can solve some of the problem here. The testing that is going on in this field requires free field testing, so they're doing it out of China Lake. And actually, you can go out and rent China Lake's facility right now. That's where Dave Schreiner has been doing his work, and they've been testing it on things like helicopters. And that helicopter, believe it or not, is sitting on a styrofoam tube. That's all it is, a piece of styrofoam. And they're subjecting it to huge amounts of the energy coming out of the S-20 and other military weapon systems that are being developed. And up there on that hoist is the detection systems that they're using to monitor the effects of what's going on. The first unclassified hearings began in 1998 on this, and we had Russians come in and some expert Americans came in to talk about it. Again, I'll give you the URLs for all of this. It'll be up here on the board. It's all out there on the internet, on U.S. government sites. The health concerns, if you guys are going to go play with this, get some copper, all right? This stuff can hurt. We've heard about with the cell phones and the brain cancer. The truth is, we really don't know. We know that HPM will fry your insides. We know that. It'll be like the people in the microwave. Clysteron tubes, radar systems. Too many sailors have died that way by getting in front of the clysteron tube while it's hot. So if you're going to be playing with this stuff, be aware it can be lethal if you really don't know what the hell you're doing. Again, that's why some fundamental engineering knowledge is really good. Keep the power down, keep the voltage up, and keep your gonads away from it. It's not good for you. If you want to play, Tesla's a good place to start. If you want to just look for the effects and all of that, Tesla stuff was great. Huge amounts of voltage, low amounts of current, no damage, skin surface, high voltage will travel across the surface of the skin in your body and not penetrate it. It's the current that will create the penetrating factor and stop your heart, which is not good. Hactic built a device several years ago over in Amsterdam, and this is made out of the Jacob's ladder, which is a voltage multiplying system, which is that rig up on top. Classic power supply, plugs into the wall, and they were trying to make some very attractive Christmas lights for the windows that took down computers for 100 yards around. So this device, they built just from scrap parts lying around, and all that's involved here is a power supply, create a capacitive bank, Marx generators. You can buy those surplus for $20, and the output on this, instead of having a tuned antenna or anything fancy, was a screwdriver and a nail. And you charge it up, click it, and you get your spark discharge. Lots of simple ways you can play with this kind of stuff. If you really want to get creative, you can do a thing called the coffin. And the coffin is, you build a big box about the shape of the coffin. And you go to Defcon, you get a whole mess of beer bottles that are empty. You fill them half with sand, half with seawater, and what do we have? We have nature's capacitors. Bank them all together, and you can create the effects. Again, this is just for educational purposes only. Capacitive discharge is the key for an awful lot of this if you want to stay out of trouble and not get hurt. Play in the electrostatic discharge, in the transient electrostatic discharge arena. Avoid the microwave arena at all costs unless you really want to take some chances with this. If you want to play, you can go out and buy some kits. Real simple kits. What's the URL on this one? FutureHorizons.net. And they sell the kits on Van de Graaff generators, Tesla stuff, in order to generate huge amounts of voltage. And then go put your computer near it. See what happens. Have some fun. If you're looking for some more research on this stuff, here's a whole mess of these. I'll leave this up for a few minutes. It's a lot of the testimony that occurred in front of Congress. There was some recent testimony 2 weeks ago down at George Washington University, sponsored by a couple of congressmen, trying to understand the effects to the infrastructure as a result of all of this. And if you're looking to buy any of these, some of the Russian devices, it's www.moose-hill.com. I thank you very much, and I'll be happy to answer any questions for you. Yes, sir. I'm sorry? There's an antenna in the front end of it. In the nose, there's an antenna. Yeah. Oh, it doesn't. That's the bomb itself. The bomb itself either drops out of the airplane or goes into a glide pattern. I didn't hear you. I'm sorry. How does the plane get away from it? I assume the military has got that one figured out on their own. I never thought about that question. I'm sorry. Yes, sir, in the back. All right, next. What do I feel? I've never seen a published study on that yet. Diodes, the front-end diodes in most of the TTL circuits and also in CMOS circuits, you can kill those with about 10 volts of directed energy right on them. From an E-field standpoint, the way that we've looked at it is more from the electrostatic discharge standpoint, which is, you're looking at 500,000 volts of electrostatics. From a microwave standpoint, HPM standpoint, you're looking at somewhere down in the milliwatt ranges because the susceptibility of the ICs is not there. I mean, is there? Intel and the Department of Energy just went into a deal, though, to start developing hardened ICs for communication satellites and stuff down here on the ground. Yes, sir. Temperature shielding will give you some protection against broadband, wide-frequency types of impingements. When you're talking narrowband attacks through apertures, it's not going to solve that whatsoever. There's an attenuation factor absolutely at certain frequencies. There's also tempest glass that will have an effect in creating Faraday rooms as well. But it's not, you're talking an attenuation factor against very specific frequencies that are common with the tempest domain. Yes, sir. No, I'm not. Yes, sir. Yeah, no, the Germans have used the EMP weapon in Kosovo. We also used a couple of them over in the Gulf War as a beta test. Yes. Yes, no, we've used them in both conflicts, to the best of my knowledge. Yes, sir. I'm sorry? In some cases, depending upon the frequencies, they are very, very efficient. A lot of the stuff, the testing that I've seen done, is just using conventional log periodic antennas. And you can tune those fairly well if you're trying to go especially for the NB-HPM versions. Yes, sir. Is law enforcement going to use this technology to stop cars? There's been a lot of discussion over that. Ireland was looking at it, State of California was looking at it. I was not aware about the border. The problem that you have is that the cars can go totally out of control, and it becomes a collateral damage issue. Shutting the car down, following folks around. To the best of my knowledge, they're not getting ready yet to deploy that. Yes, sir. You know, is the U.S. the most advanced? The U.S. certainly has this area. Russia has done a tremendous amount for a longer time than we have. We started developing flux compression generators down in Los Alamos and Sandia in the 1950s. Russia, not only in this area, but in a lot of areas, is really quite mind-boggling because they tend to look at things somewhat differently. The BAS technology for the super high-speed current switching is what is able to size. We have not been able to match that technology independently, but now that we're getting it, we're learning how to do it. Yes, sir. The formulas for across a shield, you're into engineering. You need to look up, it's written